So the test is over chapters 10 through 13. So this stuff that we're doing today won't be on that test. But it is stuff that you need. We're still building on what we're already doing. Okay, but we're looking at it a different way, looking at different things. We're not actually calculating a dosage this time. We're calculating flow rates. Okay, so we're dealing with IVs. I've got the IV solutions up here, just so when you see these abbreviations, you'll know what they mean. The D is dextrose or glucose. W is the water. S is saline. NS is normal saline, which is 0.9% of sodium chloride. So the 9/10, I mean, it's 9/10, it's not 1%, okay? It's less than 1% of sodium chloride. It's the common term for normal saline because it has the same concentration of sodium chloride normally present in the blood. Okay, I got that straight out of the book. It doesn't make, the way it's written doesn't always make a whole lot of sense. The Ringer's lactate and lactated Ringers, RL and LR, they're the same thing. They're a mixture of sodium chloride, sodium lactate, potassium, calcium, and calcium chloride in water. Okay, I don't know the difference. I couldn't figure out what the difference would be between RL and LR. The only thing I can think of is the manufacturer. One of them calls it lactated Ringers, the other one calls it Ringers lactated, because they're exactly the same thing. So how you will see it written is something like the D5W. This little 5 right here represents, it states 5%. It's 5% dextrose in water, okay? With that 5, get my pen working. So with that 5%, it's the same thing as saying 5 grams out of 100 milliliters. So for every 5 grams, I have 100 milliliters. Or every 100 milliliters, I have 5 grams. All right. And it also says it right here in the red box. Each 1,000 milliliters contains 5 grams of dextrose. Okay. But just so you know what it means. Number 2 is how an order would be written for an IV. Dextrose 10 or D10W, which is 10% dextrose in water. 250 milliliters, that's the size of your bag, and it's an IV bag, and it's given you want it to run for every 6 hours. What we're wanting to know in this one is calculate the amount of dextrose at 250 milliliters. Well, the 10 is just like the 5. The 10% is the same thing as 10 grams in every 100 milliliters. Okay. So to calculate that for 250 milliliters, we use the 10 grams over 100 milliliters, excuse me, times the 250 milliliters over 1. And my milliliters will cancel. Do this several ways. I like canceling zeros. This 0 I can cancel with this 0. This 0 will cancel with that 0. So now I'm down to 1 and 25. So 1 times 25 is 25. 1 times 1 is 1. So it's 25 grams in the 250 milliliters. So that's the total amount of grams. Yeah, you don't have to cancel. Okay, I'm doing a lot of this in my head, so I'm canceling when I can. But I like to cancel too. I don't put as many numbers in my calculator. Pretty simple stuff right now. Get y'all thinking that the math is pretty simple, really. All right. So let's get into what we're really going to do today. Not that, we're going to be concentrating on the flow rates. And a flow rate is the amount of, I've lost my pen, is the amount of fluid over so many hours. Okay, and we want to get it and write it as milliliters per hour. So we want it over 1 hour. So we're going to basically reduce it. We find the flow rate by taking our amount in milliliters, dividing it by our time in hours. Okay. For the most part, that's as simple as it gets. So we're going to take our 250 milliliters over our 2 hours. It's in milliliters per hour. So I'm simplifying. 250 divided by 2 is 125. It's 125 milliliters per hour. That's my flow rate. This chapter starts off real easy, guys. So look at number 4. This one's got a lot more information. We got ampicillin 500 milligrams IV in 50 milliliters D5 1/2 normal saline in 30 minutes by infusion pump. That should say over 30 minutes, but typo, I guess. So I'm only looking for the flow rate. To calculate the flow rate, you don't need the medication or the amount of medication. Okay. When we're calculating how much we're going to give, we need that. But to calculate the flow rate, we don't. We just need our amount in milliliters and our time. Okay. So remember, I'm wanting this in milliliters per hour. So I've got my 50 milliliters over 30 minutes, but I need it in hours. So I'm going to have to convert my minutes to hours. Okay, so y'all know how many minutes are in an hour? 60. 60 minutes per hour. Then my minutes cancel. So 30 goes into 60 how many times? 2. So we should be able to do that one. Maybe not. So then 50 times 2 gives me 100 milliliters per hour. And that's okay, right? To get to program the pump is 100 milliliters per hour because you're only running 50 milliliters. It's going to end in 30 minutes. Okay. Now, a lot of people will tell you, especially on the floor, oh, don't worry about calculating the flow rate because all you have to do is push it into the pump. And the pump will do the calculations for you. You can type in 50 milliliters, and I don't know if you type in 30 minutes or 1/2 hour, however you have to do it, and it'll calculate it and set it. But here's my thing. What if you push the wrong button? What if you're in a hurry? Instead of pushing 50, you push 40. And still over 30 minutes. It's going to run faster, right? Because it's going to run slower because I don't have as many milliliters. So you need to know how to do it or be able to estimate it well enough that once you punch the numbers into the IV pump, that rate is set and it's set at the right amount. Okay. Now, sometimes we have to do more conversions. So number 5, I have 2.5 liters in 20 hours. Okay. So we still start with our amount. Start over our 20 hours. I have to convert liters to milliliters, right? Because it has to be in milliliters. So liters is on top, liters has to go on bottom, milliliters has to go on top. So what's my conversion here? I should know. I would hope you all would know this one by now, but okay. Any guesses? 1,000 milliliters in 1 liter. It's like there's 1,000 milligrams in 1 liter. Now, do I have to convert my time?
No, so it's already an hour.
Yeah, it's already an hour, so I don't have to convert the time. So my liters cancel. You can cancel the zeros. Makes it easier. 2.5 times 100 is 250 over 2. That gives me my milliliters per hour because that's what I'm left with. What's 250 divided by 2? 125 milliliters per hour. Okay. So it's your amount of milliliters over your time in hours. You have to do the conversion if it's not. All right, so we all good? Any questions? Don't ask me questions, I'll let you know why, right? All right. So we're moving on from, and we're still calculating flow rate, but we're moving on from using an infusion pump to using gravity flow, okay? This has no pump involved. It's the flow rate calculated in drops per minute. The GTT stands, the abbreviation we use for drop. It's a Italian, Greek word or Italian word? I don't remember now. I've been saying Italian, but I'm thinking it's Greek. But it's the abbreviation for the foreign word for drop. And so it's drops per minute. It's the number of drops falling per minute into the IV drip chamber. And it's, you count them, make sure you've got the right one. But when you're doing gravity flow, you will always be given IV tubing. Okay, the IV tubing sets your drip factor. It sets how many drops are going to flow into the drip chamber. So if you've got IV tubing that is calibrated as 10 drops per minute, 10 drops per milliliter, then in that drip chamber, you're going to make sure you've got 10 drops are falling. And it's going to be falling every milliliter, and it'll fill up the milliliter. 15 drops per milliliter, 20 drops per milliliter. These are all your macro drops. These are large drops. You know, you think about it, you got 1 milliliter, 10 drops have to be pretty good size to fill up 1 milliliter, right? You know, 20 drops, they can be a little bit smaller. So they're what's considered large drops. We go down here, we've got our micro drop, or micro drop. These are smaller drops, they're 60 drops per milliliter. It's also known as a primary IV set. So sometimes the packaging will say primary IV, and it's the 60 drops per milliliter. So it's known as an micro grip. It's known as a primary IV set, and you also will see sometimes 60 drops per milliliter on the packaging. And when we work our problems in here, you will see, I will give you the drop factor, and I will give you the total milliliters. So let's go into a problem before I confuse everybody. All right, so in this one, in number 6, the order is for D5W IV at 125 milliliters per hour. Even though that's a flow rate, it's also telling me my amount, 125 milliliters over 1 hour. So the infusion set is calibrated for a drop factor of 10 drops per milliliter. Okay, so that's my drop factor. So calculate the flow rate, drops per minute. On these questions in the homework and on the test, I will just ask you to calculate the flow rate. If you're given a drop factor, you automatically calculate it drops per minute. If you're not given a drop factor, then you calculate it in milliliters per hour. Unless it says calculate in drops per minute. Then you got to do something else. All right, so I need drops per minute. Sometimes my GTT looks like GA, so I apologize. My handwriting's bad. So I have 125 milliliters over 1 hour times my drop factor. I was going to write this down. 10 drops per milliliter. So the drop factor is you're going to have your amount in milliliters over your time in hours times your drop factor is your drops. GPT over your ML times. Most of the time it's in hours, so you're going to use the time 1 hour over 60 minutes. Time conversion. So that's where I'm at here. I've got my total amount over an hour, my drop factor 10 drops per milliliter, times 1 hour over 60 minutes, because this has to be in minutes. I can't have drops per hour. I mean, seriously, would you sit there and want to count how many drops is in 1 hour? 1 minute's long enough. All right, so my milliliters cancel, my hours cancel, and I'm left with drops over minutes. And then I can take 10 goes into 60 6 times. So then I'm left with 125 over 6. And then I have to reduce 125 over 6. And I'm going to take it down to the decimal. My phone updated it and reset all my apps, so anything is anymore. So 125 divided by 6. So I get 20.83. Now, have you ever seen 8/10 of a drop? Anything I've ever seen, I've seen large drops and I've seen small drops, but I've never seen a partial drop. So when we're writing our drops per minute, we have to write it as whole numbers. So 20 drops per minute. If we round it, we're going to round it to 21 drops per minute. Either one of these are acceptable for me, okay? Because it depends on where you work. It's just like, we did the full doses. Well, if it's 9.8 full doses or 9.8 doses, I can't say that's 10 full doses, can I? It would be 9 full doses. So 20.8 drops is really only 20 drops. But some places will let you round it up to 21 drops. So it depends on the protocol there for doing gravity flow. 1 drop over a minute is not going to make a big difference. 5 drops over a minute might, but 1 drop over a minute's not. Okay. So got the difficult stuff yet?
What is DEOP?
Drop.
What is DROP?
It should be DROP.
Okay.
I told you my handwriting's.
But I know GTT means drop.
Yeah. Let's see if I can write that a little bit better. Is that better? Maybe not. I think it looks like an order. Okay. That's what I drop over factor there. All right, let's look at number 7. Okay. And again, sometimes your orders, if you're actually getting ready to prepare this on the floor, you'll need to know the 500 milligrams of ampicillin because you'll need to know what's in the bag. But to calculate flow rate, again, I don't need this ampicillin 500 milligrams. I just need my total milliliters over my total time. And it says calculate flow rate drops per minute. I don't have a drop factor though, right? So it's missing the drop factor. So what do we do if it's missing the drop factor? Do what?
Contact the doctor.
Contact the doctor. Call the physician. Ask for clarification. Call doctor. I can't spell physician. I can spell physician. I just don't want to. Ask for clarification. Doctor is easier to spell. So call doctor. Ask for clarification. I was grading. What was I grading? Test maybe. And I asked you, something was missing, and you were asked what you were supposed to do. And most of y'all put call the doctor, call the physician, call the healthcare provider. So this, I didn't got it wrong. I went ahead and you got that much, so I gave it to you. But when you talk about demanding something from the doctor, he's going to tell you where to go. And it won't be a pretty place most of the time. You don't ever demand something from the doctor. You know, it's just hospital protocol, but it's just common courtesy. You call and ask the doctor for clarification. Some of these doctors that my sister has dealt with, and she's told me stories, and some of the doctors that my daughter has dealt with from the pharmacy end, and they'll ask you, and we asked the doctor one time about some medication he was giving my husband, and because I'd heard some things about it, he looked at me and he said, "Where did you get your medical degree?" Doctors don't always have bedside manner. So don't ever demand something from the doctor. Call and ask nicely. Okay. That's just my word of caution for y'all. So we're going to call the doctor, ask for clarification. The doctor's going to tell you, "Oh, I'm sorry, I forgot to put the drop factor in there. It's 20 drops per milliliter is how I want it ran." So you're going to put in the order 20 drops per milliliter, and you're going to write it out as a verbal order, and you're going to sign your name that you called the doctor and got the verbal order. So now we've got a drop factor. Now I've got my amount. So I've got 100 milliliters over 45 minutes times 20 drops per milliliter. Do I need to do the time?
No.
No, because it's already in minutes, right? And I want it to go to minutes. So my milliliters cancel. I'm left in drops per minute. So I'm going to do 100 times 20 and get 2,000 over 45. I didn't see anything to reduce real easy, real quickly. I mean, there's something we can reduce, we just don't help all that much. So I get 44.44. So how many drops per minute would I have? 44. Whether I rounded it or not rounded, I'm still getting 44. That's going to get lost in here. So questions? Okay. So number 8 is yours. Y'all work number 8. You don't have to cancel. I remember that. I did the 15 into the 60, but you don't have to. You can multiply 3,000 times 15, 24 times 60, and divide that out. You just got great big difference between the two. Ms. Young? Yes, ma'am?
Could you just, I did mine a different way, but I came out with the same answer.
Okay, say that again, because you did it differently.
Yes, ma'am, but I came out with the same answer.
You did get the same answer?
I knew that, 24 hours equal 1440, so I just went ahead and converted it to minutes from the beginning.
That's fine. That's fine. You can do that. I don't teach that, but you can do that. And I won't count it wrong on the test. So to clarify here, what she's saying is she knows that 24 hours is the same thing as 1,440 minutes. Or 1,440 minutes. So she just went ahead and changed the 24 hours to minutes, which you can do because that's what we're doing. If I took 24 times 60, I get 1,440. So you can do that here instead of doing this conversion here. I don't teach that way because I want to be consistent all the way through. But if you can do that, remember to do that. I'm okay with it. If that works better for y'all. Because you will, or I should say, you should get the same answer. The only way you wouldn't get the same answer is if you typed a number in wrong. Okay, because it's probably the same. All right. So did everybody get 31 drops per minute? Okay. So y'all try number 9.
Oh, where'd you get that from?
The 4. Okay. 15 goes into 64 times. I played spades as a kid growing up. Aces were 15 points a piece. You always wanted 4 aces because you wanted that 60 points. And you need to teach kids multiplication tables, things like that. Card games. There's a lot of card games out there that are really good for addition and multiplication. That's not why I played it, but it really reinforced a lot of my multiplication. Okay, did everyone either get 21 or 20? On the test, you don't have, or as homework, either one. You don't have to write both, write only one of them. Okay, so give me either the 21 drops per minute or the 20 drops per minute. I give you both of them because I don't know which one you're doing. Okay, any questions about this one? This would have been the perfect one to change this hour to 60 minutes here and then not have done this. Okay. I put that 3,000. I remember that. Yeah. Okay. So remember, if it gives you a rate, you don't have to use your total amount because it doesn't give you a total amount of hours.
And the rate is that
The 125 milliliters per hour.
so long as we have that, we don't have to.
Right, as long as you have that, you don't have to use your total amount of fluid. Okay, so did everybody get the 50 drops per milliliter? When you have the 60 drops per milliliter as your drop factor, then you got to convert the hour to minutes. The easiest thing to do is to cancel those 60s. And then you don't have any multiplication to do. So number 11, what numbers am I going to use?
It's just the 25 milliliter an hour and the 60 milliliter.
And then 60 drops per milliliter, right? I don't need to know about the 20 milliequivalents of potassium fluoride, the KCl, per liter, right? I just need the rate, the drop factor. So what have we got as our drop, as our rate, or minute drops per minute? 25. Anybody get anything differently? We set it up just like we set up this other one. Instead of 50, I'd have 25. My drop factor is still 60. I still got to convert my hours to minutes. So it's going to come out to be 25 drops per minute. Questions? Okay, so you don't always run IV fluids through gravity flow, or sometimes in this case, and I just put this one up there to let you know that, sometimes it's more than just IV solutions. They're running red blood or red blood cells. They give blood. How else would you get a person? I don't want to say this. If a person needs blood, how else would they get it? Through the IV, right? So in this case, through the orders for packed red blood cells, they will 480 milliliters in 4 hours. And it's got a drop factor of 10 drops per milliliter. So y'all work that one. What did y'all get?
20.
20
Yes, ma'am.
drops per minute. All right, so now after I made you work it the long way. Isn't that nice of me? Make you work it the long way. And I made you work it the long way because you can't always use the shortcut. Okay. The shortcut method, and it uses what's called the drop factor constant. All right. So, and we've been kind of doing the conversion for it. If I take my drops per milliliter, if I take 10 drops per milliliter times the 1 hour over 60 minutes, nothing cancels, but this is how they converted it to get the drops per milliliter, because it's usually something over 1 hour. So my 10 goes into my 60 6 times. So my constant is 6. So when I take my drop factor times my time conversion, that's where they're getting their drop factor constant. So I've got a 6, the 15 drops is 4, the 20 drops is 3, and the 60 drops is 1. And what you're doing is you've got to have it in milliliters per hour, and you've got to have your drop factor constant. Okay, so you still have to know what your drop factor is. So look at number 13. I don't need the 1,000 milliliters because I've got the rate of 125 milliliters per hour. I've got a drop factor of 10 drops per minute. So my constant would be 6, right? So I'm going to take the 125, divide it by 6. That gives me drops per minute. I don't like this because I can't put my units in there and cancel my units. But 125 divided by 6, I've done this I don't know how many times. It's 20.83. So I get 21 or 20, I'm just going to put 21 this time, drops per minute. It's a little faster, but you gotta have the rate, it's gotta be per hour, and then you gotta know what your constant is. But your constant, you're just taking whatever your drop factor is and seeing how many times it'll go into 60. Okay. So if y'all try number 4, or 14, excuse me. And I will say this, I will not put any problems on the homework or on the test that says use the shortcut or use the drop factor constant. Because if you don't like this one, you don't have to use it. If you like it, you can use it.
Is it going to give us the consistent, or we just got to?
You gotta know, you gotta be able to you gotta know how to figure it out.
Yeah, so you put the 4 right, without me knowing it, how would I figure that out?
Okay, it's the drop factor, it's 60 divided by the drop factor. Okay. Okay, so did we all get 38 or 37? So what I will do on these, the questions for the drops per minute flow rate or the milliliters per hour flow rate will always say find the flow rate. Okay, you can choose whether or not to use the shortcut method, go the long way, if it's whichever one's appropriate. I'm not going to force you to use the shortcut method. I'm not going to force you to go the long way when you can use the shortcut method. I want you to do what you're comfortable with. Because I got a lot of people that like to do it both ways. And you get the right answer. Questions? All right. How hot is your brain today? Pretty good order?
No, I'm really messed up, really am.
You already messed the
It's
shortcut
just
method?
that I'm trying to keep up with the testing and then put this like to the side so I know that
Yeah.
it's kind of weird.
Well, I will put the video up for today, so you've got that to go back to if you want to just kind of forget it till after the test. And I'm going to stop here because I don't really want to get into this other. So I don't have it. I don't think I have it in this one yet.
What I did was print out the worksheets of the chapter and just try to work on them and I did like stuff out.
Yeah, it would be. You see these 3 videos I have here for chapter 13? All right, these are ones that I created last spring. Okay, so it's just like me teaching you. It's the same process. You've got YouTube videos out there that will also, let me go down here on this, find the blank space because I'm going to erase it. You can go to registered nurses. It's called registered nurses. If I spell this wrong, just don't laugh at me. Registered nurse RN, and this is a YouTube channel. And she works things pretty close to the same way I work them. Okay. You can also find me on YouTube, and they said if you'll search MATH12131, that you can find my videos. And I've got several out there. I made all my chapter videos, all my stuff is public now.
You said 1210?
12131. Which I was gonna go up there. So go to YouTube. And I have to go back so they can see my. All right. Newport Rural, can y'all see the YouTube chat, the YouTube here? And if you'll search.
No, no.
Yeah. I can't get you any other way. Okay. So, see where it's got Karen Young? You can see it's got me on some of these. But click on that Karen Young, and I'll have the math thing here going. And go to videos. You can scroll down, and I've got some that I'm going to post, but I've got college algebra as well as math for health professions. The 12131 are all math for health professions. So it's just different classes if you want to look at any of those. I teach it the same way pretty much, but I may have said something, they may have asked questions. On here somewhere is my chapter 15 videos right here. I have 15.2, 15.1. So you can find those on YouTube, but I'm going to post those on Canvas too. Okay. All right, any other questions? Go vote. If you haven't voted yet and you're registered to vote. Every vote counts. I don't care who you vote for, go vote. Trump and Pence, not Trump and Pence, Trump and Biden, thank you. I'm drawing blanks today. Trump and Biden are pretty much neck and neck. I don't know about the mayor's race. I haven't heard about it.
I don't know who to vote for this year. I didn't vote for it. I just felt very bad about it.
Or the mayor or the president?
Both.
Both.
Yeah,
I don't know anything about the guys that's running for mayor here in Jonesboro. I knew,
I don't know anymore.
I know his name. I know him. I can't think of the mayor of Jonesboro's name. Anyway, it doesn't matter. But I've been to several meetings with him, so I know him. He was a good one. I don't know, I mean, you want to vote for somebody, see who he recommends. See who he endorses. But our goal, eeny, meeny, miny, moe. But, you know, vote, because it makes a difference. All right. I will see everybody. Oh, wait, this is Tuesday, right? Never mind. I'll be here Thursday. If you want me to grade, you want to sign the sign-in sheet, sign the sign-in sheet. Girls, did you need me to stick around?